Welcome pre-calculus students to the homework help video. I am doing this video during the day instead of the nighttime, so my kids are awake, so there will be some background noise, so please understand that. We're looking at page 472, these numbers right here. Please go ahead and turn your books to this page, page 472. Get out your calculators and notebook paper, and let's get started on this homework assignment. All right, let's take a look at numbers 25 and 27. The directions say find the 6 trig function values for the angle that's shown. Now please listen carefully and take some good notes here as we work this homework out together and follow along. Notice that the angle starts here and goes around once and then some more and stops right here. So the angle we're dealing with is this whole angle that goes around. But remember what you learned today. You learned that reference angles will also help you find the trig functions. So if I use this angle right here inside my triangle, I should be pretty much home free. So I'm going to go ahead and draw a dotted line straight down and see this ordered pair. It says this point is over 12. Do you see that? This point right here is over 12. So I know the length of this line is 12 and the ordered pair is up 5. So I know the length of this line is 5. So basically what I have now is a right triangle, which is cool. I mean, here it is. Look, here's my right triangle. And with theta right here. So all that I have to do now is use that right triangle, and I should be pretty much home free. So here's my right triangle right there. And here's theta right here inside. This is 5, this is 12. And using Pythagorean's theorem, let me quickly use a calculator here. Using Pythagorean's theorem, I should get 13. I'm not going to take time to do that. By now, we should know how to use L squared plus L squared equals 8 squared. I have a leg, so 5 squared. I have a leg, so 12 squared. 5 squared plus 12 squared is 169. Take the square root of that, and you get 13. So there's all 3 sides. Now, remember your sign sequence for this quadrant is positive, negative, negative. So I'm going to go ahead and find the sine of theta. And the sine of theta would be opposite over hypotenuse, 5/13, and notice sine is positive. Now we're going to find the cosine of theta, and the cosine of theta is adjacent over hypotenuse, so 12/13, but notice cosine is negative in this quadrant, so negative. And then tangent of theta is opposite over adjacent, so 5/12, and notice that tangent is negative in this quadrant. So there we go. So now quickly find the other 3 trig functions. The cosecant of theta would be the inverse of sine, so 13/5. And the secant of theta would be the inverse of cosine, so negative 13/12. And the cotangent of theta would be the inverse of negative 5/12, so negative 12/5. Moving on to number 27. All right, now here's the angle we're dealing with. Notice it starts right here and goes to here, has an arrow. That's the angle we're dealing with, okay? But remember, we can just use the reference angle, which would be, I'm going to put a dotted line right here, which would be this angle right here. So basically, notice what I have. I have an ordered pair right here, and I know that I'm over, here's my x value right here. I'm over negative 2 square root of 3. And here's my y value. I'm not sure why I put a negative with that. It's distance, and distance is never negative. So I know that I'm over negative 2 square root of 3. So the distance of this line from here to here would be 2 square root of 3. And then I know this ordered pair is down negative 4, so the length of this line here is 4. So I've got a right triangle right here. Here's my right triangle right here. And here's theta right here. So all that I have to do is simply draw that right triangle right over here, and then go ahead and put theta right here like this, and then label this side 2 square root of 3, and label this side 4, and then find the hypotenuse using Pythagorean's theorem. Now let's go ahead and find the hypotenuse by using Pythagorean's theorem. I will go ahead and do this for you. This was a little more difficult than the other one. So one leg is 4, so 4 squared. The other leg is 2 square root of 3 squared equals hypotenuse squared. Well, 4 squared is 16. And if you type this into your calculator, students, 2 square root of 3 times 2 square root of 3, you should get 12, I believe. 4 square root of 9, yes, you'll get 12 equals h squared. Add these together, you would get 28 equals h squared. So the square root of 28 would be what we're looking at, square root of 28. Now really you should have learned this in the past. You really should have, guys. The square root of 28 is the same thing as the square root of 4 times 7. That's algebra 2. Okay? And we know the square root of 4 is 2. So the square root of 28 is really 2 square root of 7. We learned that in algebra 2. So let's go ahead and put 2 square root of 7 right here instead of the square root of 28. Okay, and let's go ahead and get started very quickly. Let's say the sine of theta would be opposite over hypotenuse, so 4 over 2 square root of 7. And of course, if we multiply that out, we would really get 4 square root of 7 over 14. If you multiplied the square root of 7 times the top and the square root of 7 times the bottom, and then of course that would reduce, the 4 and the 14 would reduce, so we would have 2 square root of 7 over 7. Now let's take a look at cosine of theta. Cosine of theta is adjacent, which is 2 square root of 3, over hypotenuse, which is 2 square root of 7. I'm going to go ahead and reduce this first, cross off those 2's. Now multiply the top and the bottom times square root of 7, and you'll get square root of 21 over 7. Do not reduce that because one's an inside number and one's an outside number. But what I did is I multiplied the top and the bottom by the square root of 7. Now moving on to tangent. Tangent of theta is opposite over adjacent, so 4 over 2 square root of 3. I'm going to go ahead and quickly reduce the 2 and the 4. The 2 becomes a 1, and this becomes a 2. Multiply the top and the bottom by the square root of 3, and you would get 2 square root of 3 over 3. So there we go, moving right along. Now let's take a look at the inverse of sine. The cosecant of theta is the inverse, and so we would have 2 square root of 7 over 4, and the 2 and the 4 would reduce. 2 would go into both of those, so we would have square root of 7 over 2. Now let's take a look at secant of theta. I'm going to take this right here, and I'm going to flip it, so I would have square root of 7 over square root of 3. And now let's multiply the top and the bottom by the square root of 3, and you would get square root of 21 over 3. And now we have cotangent of theta, and so the inverse of tangent, we had what? 2 over square root of 3. So if you flip that, you'll get square root of 3 over 2. Do you see it? Hold on one second. Do you see it right here? I had 4 over 2 square root of 3. I reduced my 4 and my 2, and it became 2 over 1 square root of 3. And if you flip that, you'll get square root of 3 over 2. All right? So that's how you do numbers 25 and 27. Okay, moving on to 29 and 31. The terminal side, the directions say the terminal side of angle theta in standard position lies on the given line in that quadrant. Find sine, cosine, and tangent. So here's what we have. We have a linear equation that is 2x plus 3y. Okay? Now all of these lines, just so you know, are going to start, trust me, they're going to start at the origin, okay? So I'm going to go ahead and just draw a line coming out. In fact, I'm going to back that up, and I'm going to use this so it's a little better. Now just watch what I do, please, students, watch. All right? Now, here's the thing. I know I'm in quadrant 4, so that's why I drew the ray coming out, okay? I'm going to go ahead and put a little theta right here, okay? And then, oh, let's go back one. You know what I forgot to do over here, and I sincerely apologize for number 27. I'm so sorry. I forgot to check my signs, didn't I? The sign sequence is negative, negative, positive. So sine should be negative, cosine should be negative, tangent should be positive, cosecant should be negative, secant should be negative, and cotangent should be positive. I apologize for forgetting that. And let's not forget that in this problem here. Our sine sequence here is negative, positive, negative. Okay? All right. Now, what we do is we want to look at this linear equation and find a point that lies on this line coming out right here that satisfies this equation. Now here's what I'm going to do. See if this makes sense. Please watch carefully, students. I don't want to put a number in for x like 1. Because if I put a 1 in for x and then solve for y, I would get 2/3. So my ordered pair would be 1 comma 2/3. And who wants a fraction? I don't want to work with a fraction. So you can put any number you want in for x. So you have the liberty to do that. But let's use common sense. I mean, I'm trying to think of putting a number in for x like 3. Because I know if I take 2 times 3, I would get 6. And when I bring the 6 over and make it a negative 6, 3 goes into 6 evenly. So what I'm going to do is I'm going to put 3 in for x. Now let me say this again. You're more than welcome to use any number for x that you want to. But I'm using a number that'll give me out whole numbers for y. And that makes a lot more sense to me. Now 2 times 3 is 6. So again, for the third time, some of you are saying, Mr. Earhart, where did you get 3 for x? I just picked that out of random. You can use any number you want. I chose 3 because 2 times 3 is 6. And now watch what happens when I bring this 6 over and make it negative. When I bring the 6 over and make it negative, 3 goes into negative 6 evenly, and I get negative 2. All right? So that's why I did that. So now I have an ordered pair that lies on that line. You do? Well, yeah, I do, sure. What did I put in for x? 3. What did I put in for y? I mean, what did I get out for y? Negative 2. So I definitely have an ordered pair that falls on that line. So there's my ordered pair. Now that's a big deal because now I can go like this. I can come over here and I can go over 3 and down 2 and put a point right here. And now I've got a nice right triangle. I went over 3. So there's my right triangle. And I know this is 3 over 3 and down 2. This is 2. So there's my nice right triangle right here. There's my right triangle, more or less. There's my right angle. See this 3 right here? Here's my 3. See this 2 right here? Here's my 2 right here. And now let's find the hypotenuse. It would be the square root of 13 if you use Pythagorean's theorem, square root of 13. So all they want us to find is sine, cosine, and tangent. Oh, where's theta, by the way? Don't forget. Here's theta right here in this corner. See it? So theta is right here. So sine of theta would be opposite over hypotenuse. That's 2 over square root of 13. If you multiply the top and the bottom of that square root of 13, you get 2 square root of 13 all over 13. Wow, my computer's messing up, guys, so just hold on a second while it catches up. There we go. And notice sine is negative in this quadrant, so I'm going to put a negative sign right there. Now let's find the cosine of theta. The cosine of theta would be adjacent over hypotenuse, 3 over square root of 13. Multiply the top and the bottom by square root of 13. We get 3 square root of 13 over 13. And notice cosine is positive in this quadrant. So I'm going to put a positive sign. And now let's find the tangent of theta. So the tangent of theta is opposite over adjacent, 2/3. And notice that tangent is negative, so negative 2/3. Negative 2/3. All right, let's try another one. Number 31. Okay, we know we're in quadrant number 1. Do y'all see that? Quadrant number 1. So I'm going to go ahead and draw my ray coming up. There's quadrant number 1. And let's see. Again, I can put any number in for x that I want to, but students, let's use common sense here. I mean, I want to put a number in that when I multiply the 5 times that number, I get a number divisible by 4. I think I'm going to put 4 in for x like this. Watch what happens. 5 times 4 minus 4y equals 0. 5 times 4 is 20 minus 4y equals 0. Now bring the 20 over and make it a negative 20. Negative 4y equals negative 20. Now divide by negative 4 and you get 5. There we go. So now I know that when I put 4 in for x, I get out 5. So my ordered pair would be 4, 5. So there's my ordered pair right here. 4, 5. I put a 4 in for x and got a 5 out for y. So we'll put the ordered pair about right there. I'm going to go ahead and roughly sketch my right triangle. Come over, come down, come up. Here's theta right here. Now, I go over 4, so this is 4. I go up 5, so this is 5. And now we have to find our hypotenuse. I'm going to go ahead and do it off to the side over here. So here's my triangle that I have. There's my triangle. And let's see, this is my right angle. This is 4. This is 5. This is theta. So 16 plus 25 would be 41. So we have the square root of 41 for the hypotenuse. Now hold on one second, please. All right, now all we're looking for, let's look at our sine sequence. Everything in the first quadrant is positive, so that's pretty easy. So the sine of theta would be opposite over hypotenuse, so 5 over square root of 41. Let's rationalize, and you would get 5 square root of 41 over 41. Now let's find the cosine of theta. The cosine of theta is adjacent over the hypotenuse. Multiply the top and the bottom by the square root of 41, and you get 4 square root of 41 all over 41. And then tangent of theta equals opposite over adjacent, 5/4. So there we go. Moving along, doing good. Number 33. All right, find the other 5 function values, give exact answers. So we're in quadrant 3. So we're over here, and the sine of theta is 1/3, negative 1/3. So let's be really careful here. We know we're in quadrant 3, so let's draw our ray coming out. There's our ray. All right. Now, here's theta right here. Let's go ahead and draw our right triangle coming down like we always do. There's the right triangle. And now, what do we know about sine? The sine of theta is 1/3. Well, don't forget 1 is your opposite and 3 is your hypotenuse. So opposite would be 1. Hypotenuse would be 3. And this would be square root of 8. Now, I got square root of 8 by using Pythagorean's theorem. I have a leg, which is 1. I have the hypotenuse, which is 3. So leg squared plus leg squared equals hypotenuse squared. And if you solve that, you will get the square root of 8. But let's not forget the square root of 8 is really the square root of 4 times 2. And you can cross off the 4 because we know the square root of 4 and put a 2 on the outside. So we really have 2 square root of 2. And it's real important that we do simplify like that, okay? All right, so moving on. Let's go ahead now and find the 5 other values. We already know sine. Let's look at our sine sequence here. It's negative, negative, positive. So cosine of theta would be adjacent over hypotenuse, so 2 square root of 2 over 3, and it would be negative. Tangent of theta would be opposite over adjacent, so 1 over 2 square root of 2. And if you rationalize that, you would get square root of 2 over 4. Okay? If you multiply the top and the bottom by the square root of 2, 1 times square root of 2 is square root of 2. Square root of 2 times square root of 2 is 2 times your 2 right here would give you a 4. So that would be your tangent. So sine, cosine, tangent. Now let's look at cosecant. Cosecant of theta is the inverse of sine. So here's sine. Sine is negative 1/3, so cosecant of theta would be negative 3 over 1, or negative 3. Secant of theta is the inverse of cosine. So here's cosine right here, negative. So I flip it, I would get negative 3 over 2 square root of 2. Now if I rationalize that, I would get 2 square root of 3. Excuse me, that's incorrect. I apologize. I would get 3 square root of 2 over 4, and don't forget it would be negative. So there's the secant. And now cotangent of theta would be the inverse of tangent. Now here's tangent, 1 over 2 square root of 2. So we flip that, and we're going to get 2 square root of 2 over 1, or just 2 square root of 2 if you choose, okay? So there we go, not too bad. Let's take a look at number 35. Now number 35, we realize that we are in quadrant 4. So I'm going to go ahead and draw my ray coming out here in quadrant 4. And now, let's go ahead and draw our triangle like we always do. So coming over, coming down, here's theta, right angle. Now, Let's see what we got here. Cotangent of cotangent of theta is -2. I can put -2 over 1. So cotangent of theta is -2 over 1. Now, tangent, don't forget, of theta would be what? TOA, opposite over adjacent. And we know cotangent is the inverse of that, right? So if tangent is opposite over adjacent, then cotangent would have to be adjacent over opposite. So here's theta. My adjacent side would have to be 2. My opposite side would have to be 1. Do you see that? Opposite side, adjacent side. So my hypotenuse would have to be square root of 5. If you use Pythagorean's theorem, square the leg, add them together, take the square root, you will get the square root of 5. So there's the triangle that I need. I already know what cotangent is, so we're ready to get started. Oh, don't forget about your signs over here. It'd be negative, positive, negative. So sine of theta, I'm going to give myself a little more. I'm really getting tired of running out of room over here. So we're going to do this and that and that. There we go. All right, let's go ahead and take a look at sine of theta. Opposite over hypotenuse, 1 over, sorry guys, computer's messing up again, 1 over square root of 5. So multiply top and the bottom by square root of 5. We get square root of 5 over 5. And notice sine is negative in this quadrant, so negative. All right. Cosine. Cosine of theta would be adjacent over hypotenuse, so 2 over square root of 5. Multiply the top and the bottom by the square root of 5, and you would get 2 square root of 5 over 5. And notice, and again, guys, that's not me messing up. The computer's kind of freezing up. Notice cosine is positive, so my answer here would be positive. Now, tangent of theta would be opposite over adjacent, so 1/2, but it's negative. Notice tangent is negative in this quadrant, so negative. And there's that answer. Now, cosecant, of course, is the inverse of sine, so 1 over square root of 5, flip that, and we get square root of 5. And notice it was negative, so this will also be negative. Now, secant is the inverse of cosine. Cosine is 2 over square root of 5, so I would get square root of 5 over 2. And notice cosine is positive, so secant would also be positive. And then cotangent we already know right here. All right, let's take a look at one more of these types, then we'll move on to some other problems, and we'll try to get this done as quickly as possible. Okay, we're in the fourth quadrant again, so please make note of that. So here's my ray coming out here in the fourth quadrant, and I'm going to go ahead and draw my right triangle, coming over, down, and then here's my right angle. Here's theta right here, and then we know cosine. Now cosine is adjacent over hypotenuse. So here's theta. Adjacent would be 3. Hypotenuse would be 5. Don't forget your sign sequence for this quadrant is negative, positive, negative. And if you use Pythagorean's theorem, 3 squared plus leg squared equals 5 squared, you will get 4 for this side right here. Okay? Trust me, you will get 4. And let's go ahead, get us a little room here, and let's get started. Let's start off with the sine of theta. The sine of theta is opposite over hypotenuse, so 4/5. And notice it is negative in this quadrant. We already know what cosine is, so we'll skip that. Tangent of theta would be opposite over adjacent, so 4/3. And tangent is negative, so negative 4/3. Now let's go to cosecant. Cosecant of theta is the inverse of sine, so it'd be a negative 5/4. The secant of theta is the inverse of cosine, so here's cosine, 3/5. So the inverse of that would be 5/3. And then cotangent theta would be the inverse of tangent theta. And the tangent of theta is negative 4/3. So the cotangent of theta would be negative 3/4. Okay? And you've waded through the hardest part of the assignment. The rest of it's actually pretty easy. So here we go. Let's take a look now at number 41. All right, here we go. I'm going to quickly draw my coordinate plane. I'm not going to try to be neat. I'm going for speed. We're looking at an angle that's negative 135. So watch carefully, please. I go 90 degrees and then 45 more and draw my terminal side. There's my terminal side. Okay. And so this is negative 135. Now, what's the reference angle for 135? Well, it would be inside this triangle right here. It would be 45 degrees. So there's my right triangle. There it is right there. All right. So I'm going to pick that up and draw that right here. And actually, let's not forget our special triangle in which we know 45 degrees. We have a 1 here and a 1 here and a square root of 2 here. So we'll use this triangle here, and we're trying to find the tangent of negative 135, which is the same thing as the tangent of 45. Just remember, though, in this quadrant, tangent is positive, so I can find the tangent of negative 135 is the exact same thing as find the tangent of 45 degrees. Sorry guys, my cell phone is going off. There we go. Let me turn that off. So find the tangent of negative 135 is the exact same thing as find the tangent of 45, as long as you realize that in this quadrant, tangent is positive. So I really have tangent of 45 degrees. So here it is right here. Opposite over adjacent, so 1. So the tangent of 45 is 1, and in this quadrant it's positive. So there we go. So the tangent of negative 135 is 1. You just found the tangent of negative 135. All right, let's find the cosine of 495 degrees. Now, we're going to start right here and go around once. That's 360. Plus 90 more is 450. And then 45 more would be 495. So there is 495 degrees. Do you see that? So what's left over inside my triangle right here, my reference angle? It's 45 degrees. So I found the reference angle. Now what is cosine in this quadrant? Well, the sine sequence goes positive, negative, negative. So cosine's negative. So you are more than welcome to say that the cosine of 495 is the exact same thing as the cosine of 45. You're allowed to do that as long as you realize whatever answer you get out will be negative. It will be negative. Now let's go back a page. Cosine of 45 degrees. Here it is right here. That would be adjacent over hypotenuse, 1 over square root of 2. So I would get, let me quickly do this. Pull this over. I would get negative 1 over square root of 2, which is the same thing as negative square root of 2 over 2 when I rationalize my denominator. And again, sorry, the computer's freezing up. All right, now let's move on to number 49, the cotangent of 570. Now, let's go around once. That's 360. Plus 90 is 540. Plus 90 would be 630. Don't think that's correct. Let's see, 360 plus 90 is 450. Plus 90 is 540, and I want 570, so I'll have to go 30 more degrees. So I go 30 more degrees and draw my terminal side. So the reference angle for 570 would be 30 degrees. Do you see that? And so that means my right triangle is right here. So I'm going to draw that off to the side here. Here's my right triangle right here, just like that. And here's 30 degrees way up here. And I'm trying to find the cotangent of 570, which students, the cotangent of 570 is the exact same thing as the cotangent of 30, as long as you don't forget to check your signs. You've got to check your signs. And in this quadrant right here, tangent is positive. So cotangent would also be positive. So positive sign. And now how do I find the cotangent of 30? Well, think about that special triangle I taught you guys how to draw. Okay, this is 30 up here. This is 60 down here. This would be 2. This would be 1. This would be square root of 3. So there's your special triangle. The cotangent of 30. Well, what is cotangent? Cotangent is hypotenuse over adjacent. It's the inverse, excuse me, that's incorrect, I apologize. Cotangent is adjacent over opposite. Adjacent over opposite, which is the inverse of tangent. And so adjacent is square root of 3 over opposite, which is 1. So square root of 3 over 1, which is square root of 3. All right, moving on now to number 53. Number 53. Okay, the secant of 90, students, very quickly we draw our coordinate plane. It's a negative 90, so we rotate downward from the x-axis to 90 degrees like this. And this is called a quadrant angle or an axis angle. Notice it lands right on the y-axis. So in that case, instead of finding a reference angle, I'm going to point out to you that you're more than welcome to use your calculators to find the secant of 90 degrees, okay? But it's going to be a little difficult, so please follow my instructions carefully, okay? And see if this makes sense. First of all, the inverse of secant is cosine. So I'm going to type in the cosine of 90 degrees. So go ahead and type in the cosine of 90 and see what you get out. You get out 0, okay? Now I want to teach you something here you need to know. If the cosine of 90 is 0 and you flip 0, you get 1 over 0, and that's undefined. Let me say that again. You're trying to find the secant of 90 degrees, right? Sure we are. And so in order to find the secant of 90, we're going to find the inverse, which is cosine of 90, and then whatever we get out, we're going to flip it. So I type into my calculator the cosine of 90 and I get out 0. So now I'm going to flip 0. 0 is really over 1. Well, when you flip that, you get 1 over 0. And you can never have 0 in a denominator, so that means the secant of negative 90 is undefined. There is no secant of 90 degrees, or negative 90 for that matter. All right, let's take a look at 57. Tangent of 240. All right, here we go. Coordinate plane, pretty sloppy, but we're trying to go fast. 240, there's 180 plus 60 more would be 240. So there we go. My sine sequence here is negative, negative, positive. My reference angle would be 60 degrees. So when we're looking for the tangent of 240, that's the exact same thing as finding the tangent of 60. It's identical as long as you remember to check the sign. And in this case, the sign will be positive, so I'm going to go ahead and put positive. Now, do you remember our 30, 60, 90 triangle? It's right back here, a couple pages. Remember, here it is, right here. I'm going to go ahead and copy and paste that real quick. There it is. And so now we're going to find the tangent of 60. So here's 60, opposite over high, opposite over adjacent, opposite over adjacent. So square root of 3 over 1, which is just square root of 3. So the tangent of 60 is square root of 3. So the tangent of 240 is the square root of 3. All right, cosecant of 225. Well, let's go ahead and draw our coordinate plane like we always do. We're going to go 180 plus 45 more, okay? So the reference angle for 225 is 45 degrees, okay? So really, if I'm trying to find the cosecant, oh, don't forget your signs, by the way. The sign sequence would be negative, negative, positive. Don't forget that. So if I'm trying to find the cosecant of 225, that would be the exact same thing as finding the cosecant of 45 degrees. It's identical as long as you remember to check your sign. And the inverse of cosecant is sine. And what is sine in this quadrant? Sine is negative. So you know your answer is going to be negative. Now, how do I find the cosecant of 45? Well, I'm glad you asked. Let's go back a couple pages to where we had our special triangle. Here it is right here. I'm going to copy and paste this real quick. All right, there we go. And let's yank it down here if this is going to work. And if it doesn't, I apologize, students. I might have bitten off more than I can chew, to be honest with you. Yeah, we shouldn't have done that. Okay, well, we all make mistakes. We'll just go ahead and draw the triangle right here. Put our negative sign back. Okay, here's our 45, 45, 90 triangle. So here's 45 degrees. You should have had this memorized. We should know there's a 1 here, and a square root of 2 here. So the cosecant of 45 degrees, cosecant of 45, well, you know what? The cosecant of 45, I could find the sine and then invert it. But to be honest with you, if the sine of 45 is opposite over hypotenuse, then the cosecant has to be hypotenuse over opposite. Let's say it again. If we know the sine of an angle is opposite over hypotenuse, then the cosecant is hypotenuse over opposite. So here's 45 degrees. The hypotenuse is square root of 2, and the opposite is 1, so negative square root of 2 over 1. So if the cosecant of 45 is this right here, then the cosecant of 225 is the same thing, negative square root of 2. All right, number 65, the cotangent of negative 90. This will be interesting. Let's see what happens here, okay? Let's go ahead and draw our coordinate plane. We know we're going to rotate down 90 degrees like this, and then we have one of those situations where the angle falls right on the axis. So we're going to use our calculators. Now we can't type in the cotangent of negative 90, okay? But we can type in the tangent of negative 90. So I'm going to type in the tangent of negative 90 and see what I get out. So the tangent of negative 90 is undefined. It should have came up on your screen. Quit, does not work, domain, but in other words, it doesn't work. Now think about that. If the tangent of negative 90 is undefined, now think about this. This is going to sound kind of funny, but if I flip undefined, because I'm trying to find the cotangent of negative 90, so I first find the tangent of negative 90, and whatever I get, I flip it. Now think about it. If I have 1 over 0 right here, and I flip that, let me rephrase that. If I have 0 over 1 right here, and I flip that, I get undefined. So going backward is also the same. If I have undefined for tangent, and I flip undefined, when you flip undefined, trust me, you get 0. So if the tangent of negative 90 is undefined, flip undefined, the cotangent of negative 90 will be 0. That is correct. All right, let's take a look at number 69, 270 degrees. Well, we're going to start here, and we're going to go 90, 180, 270. So we're going to hit right on the axis, aren't we? Do you see that? So that's going to be a calculator problem. Whenever it lands right on the axis, you are more than welcome to use your calculator. So I'm going to go ahead and type in the cosine of 270, and the cosine of 270 will give me 0. So the answer is 0. Moving on to number 73, 194. Now what they want us to do, now we're in the last section of the homework, and it says find the sines of the trig function values for the given angle. So all we're doing is finding the sines, okay? So let's take a look at this. 194 degrees. Let's see what quadrant that would put me in. Here's 90, here's 180, and then 14 more degrees. So I know I'm in quadrant 3. Everybody see that? So I went from 90 to 180 to 14 degrees more. So I know 194 degrees stops right here, and I know I'm in quadrant 3. Now the sine sequence is negative, negative, positive. So that simply means that the sine of 194 would be negative, the cosine of 194 would be negative, and the tangent of 194 would be negative. I think they said to find all 6. Yes, they did. This is really easy though, guys. Cosecant of 194 would be this tangent would be positive, sorry, positive. Cosecant of 194 would be negative. Secant of 194 would be negative because cosine's negative. And the cotangent of 194 would be positive because the tangent of 194 is positive. That's all they want you to do is just find the correct sine. And let's see what we got here. Last problem, which would be number 77. Let's take a look at this one. First thing we should do is draw our coordinate plane like we always try to do. And let's see what quadrant we're dealing with. Negative 272. There's 90. There's 180. And then there's 270. So 272 barely goes right here. So there's negative 272. So we know we're in the first quadrant. And of course the sine sequence here is positive, positive, positive. So I'm just going to say sine is positive, cosine is positive, tangent is positive, cosecant is positive, secant is positive, and cotangent is positive. Way to end on a really easy one, huh? All right, I hope this video has been a big help to you. Call or email if you have questions, and please continue to work hard.